Sorry about that. These newfangled computer things, I don't really get on with them. Right, Roboglock, which some of you may have heard, been tinkling over there in the corner, is a Robot Glockenspiel. It plays its own music that it makes up using a really, really dumb algorithm. I wish I'd spent more time on it. You'll see that in a minute. And it's based on an Arduino and a PIC. Right. There are two sides to the circuit, the side that makes the noises and the control side. The Arduino on the noisy side drives a shift register so that we can control any number of strikers off of just 3 pins. I was going to put more on, it's only got 6. And the shift register drives a whole bunch of MOSFETs, so I can put loads and loads of current through, which, believe me, these solenoids need. The MOSFETs drive solenoids which are made out of viros with coil hand wound around them, about 200 windings, I think. Yeah, I know, the solenoids are expensive.
Give me money, not Arduinos.
Yeah, give me money. And then the actual strikers are screws with a couple of neodymium magnets on the top, because that really increases the force. It gives the feel sort of push against. Current drain is a problem because the coils have, I think, a resistance of 2 ohms. So as soon as you try and just pull current straight through them without a current limiting resistor, I found the Arduino would crash because the voltage regulator couldn't keep up. A tiny little 7 ohm resistor in the way just managed to get it right without putting current down too much. So I still heard the noise. And currently, inside the black box there are 7 LEDs that are working as flybacks. So that when the field across the coil collapses, the current that starts flowing in the opposite direction makes the LED go bright, which is really useful for testing it. That's the circuit. Well, hey, not a very clear diagram, but there we go. These are the MOSFETs, these are the coils here, that's the LED, that's the flyback. We've got the big Arduino on the left powering the shift register there, which is powering the MOSFET, which is powering the solenoids. And these are the other interesting bit. Those 2 lines go to a PIC. And the Arduino communicates with that. There's some code on that in assembler. And there is a bit-banged 2-wire serial interface. The PIC controls 4 LEDs and reads 8 switches, which is how it does its control. And then the Arduino every now and then says, what are the switches saying? And I'd like you to tell the LEDs to indicate this. Very simple. This is how it does the music. There are 2 sequences of numbers. They're just arrays. And they can be of different lengths. And it just goes around each one in turn. Like this. So you go... And now you're 1 out. So they go in and out of phase with each other. The way the notes are encoded is there are 6 strikers. And they're encoded on a pentatonic scale. The idea being that if you play 2 notes on a pentatonic scale, they tend to go quite well with each other. You can't really make a mistake. Cheating. The first 6 values, 0 to 5, are note strikes. Anything above that is a rest. So you can see that would encode as rest, note. And that would encode as note, note, rest, note. When you put the 2 of them together in a loop, you can see the bottom one being 4 beats long, just repeats neatly over those 4-bar phrases I've arbitrarily put there. 4 measured bars. While the top one drifts in and out of phase with that melody over and over. Does that make any sense? I am glad. And then every now and then, by default, once every 50 notes, it does one of these 4 things. Either makes the sequence longer, that you need up in the end, shortens the sequence, changes the note at random, or just completely throws away one of the 2 sequences and starts again. Right, yeah, the interface. It's awful. It really is terrible. There are 3 of the switches are set to be an address of one of the registers. 4 of the switches are data switches. So if you want to change, say, the tempo, you have to set the address bits to say, I believe, 4, which would be 100, the data bits to be whatever you want that to be in binary, and then flick the right enable switch. And those are the registers I've got. Mode is 0, 1 or 2, where it's stop, test, stop, run and test. Seed 1 and seed 2 control the random number generator. Tempo is obvious. Pause just stops the whole thing if it's non-zero. Mod rate changes the rate at which the modifications occur. Oh, there's no pause there. How did that happen? That'll be 1 o'clock in the morning. Sparsity changes the way the random number generator assigns to the notes. So normally a note is a value between 0 and 20. So 0 to 5 are going to play and the rest are going to be rests. If you increase that, you get a lot more rests. And special events, I use that so I can, if I'm bored of what it's doing, I can just tell it to change everything, or tell it to set both sequences to a length of 10, or there's another one, I forget what it is. I think I've got through this possibly. That's it. Thank you. It's not very inspiring, it's there in the core if anyone wants to do it later. Any questions? Yeah?
What kind of clarification do you have?
Why did I do it?
What kind of a bastard question is that?
I did it because I learned about how to power solenoids. I learned about how to use MOSFETs properly. I learned about how to get a PIC and an Arduino to communicate with only 2 wires. I learned loads of stuff, that's why I did it.
Huzzah for learning, Jim.
Anyone else?
Why do you want the Arduino, Jim?
I'm not that bothered actually, to be honest. The thing is, I bought a whole load of 80 Mega 328s with the bootloader on them, which are about, what, £3? And then you can build an Arduino on a breadboard. So,
Jim's the undercut, really.
so, I mean, if somebody wants to give me an Arduino, I'll say no.